Thanks for having me here. Actually, Kubernetes or AI, these are the two important things these days. So, WebRTC and Kubernetes are both very simple and easy things, so why not double the fun and mix them together? I'm Nagy from L7MP Technologies, and why do I think that I'm entitled to talk about this topic? Actually, I don't. So, we are coming from a different background to WebRTC. So, L7MP is a group of friends we met at the university a couple of years ago, and we have been working with data plane, packet processing, media plane optimization, so really low-level stuff. And from that, we turned into this company 2 years ago. We have a passion to create new products and to play with things. Yeah, I forgot to say that we are based in Budapest, Hungary. And what else? Yeah. What to expect today? I have to warn you that maybe you will find that I'm trying to sell Kubernetes to you. Yeah, I try not to. But also we have to admit and highlight all the challenges that you may face on the way on moving to Kubernetes. So we'd like to give an overview, a trend on how we see it. Okay, so the first question, how did we meet with Kubernetes in the first place? So our first impression was really good on this mindset shift that we faced. Because of the Kubernetes control plane works in a declarative manner instead of this imperative one. So I think everybody in this room have ever written a shell script or running some workloads in OpenStack where you give the sets of instruction to the system, and finally, hopefully, it will get into a state that you desire to have. In opposite, in Kubernetes, it was really fancy to see that you just have to state what final state you would like to get into, and the system under the hood will get into without your direct instructions. Also, operator patterns was very appealing at that time. I don't know how much you know about Kubernetes and operator pattern. Basically, in a simple terms, you can define your custom resources in Kubernetes, which are objects, and these operators can work on them, and they basically keep track of the life cycle of your product. And in that way, you can ensure that it's always up and running and is scaling in the right way and stuff like that. Also, you see some animals on the screen. So it reflects the first impression that we had. So in this HTTP world, these workloads are really treated as kettles. So I don't know if you are aware of this analogy, this pet versus kettle, but whenever you have a workload that you just shut down or cut off, then without any user experience or any decrease in user experience, then you can say that your workload is stateless and basically, you can say you are cloud native or stuff like that. I don't like this terminology that much, but it gives you some flexibility. And on the other hand, if you are coming from the communication world or networking world where you are coming from, we usually have these paths that you have to take care of, like setting configurations, and you have to stroke them and treat them carefully just to be up and running. And there is a gap, or at least we felt that there is a gap between these two worlds. And it turned out to be true. So if you at that time we went to Stack Overflow and checked some issues with all these problems, because our first try was to put telecommunication services into Kubernetes, and you will face really major issues there. So it is not tailored to the UDP RTP workload in the first place. There is this NAT problem, this network address translation. So basically, all the streams are described by these 5 tuples. I will have a slide on that. And also, latency comes in. But on the other hand, so this is really new technology, cool stuff. Of course, it's hard to learn. And usually, if you are a good engineer, you don't like to implement new stuff and start to learn new technologies. But anyway, so it was interesting to see that. So our idea was why not come up with a WebRTC media gateway Kubernetes? And it was called Stunner. And we made it to the CNCF landscape. I believe it's under service proxy. It is on GitHub, open source, fully open source, so you can find it there. We are also contributing to the Pion library. Actually, Stunner is built on the Pion library. And what is Stunner? Just one slider of that, because I don't want to talk a lot about that. So the two messages that I would like to give you here about Stunner is that we stopped thinking about turn service like a standalone, far away service which is far away from the media server. But instead, we thought that maybe a good way to reuse the turn protocol and turn functionality would be to think about it like an ingress gateway coupled with a media server. And by doing that, the net problem is solved, so you can ingest traffic into the Kubernetes, and by doing that, you can scale your media servers in the cluster by only exposing a single IP address and port. I will not go into a lot of details on that. We have a Medium web page where we, from time to time, come up with some technical posts, so I would encourage you to go there. We also have, I think, a pretty well-documented GitHub repository, and we have a Discord channel. So if you go to l7mp.io, you will find the Discord channel, and we are happy to discuss things related to Stunner, Kubernetes, WebRTC, so anything. Okay, so what are our users' journey with Kubernetes? How do we see that? Basically, I think the most classic sentence I used to see in the GitHub issues or Discord studies, I'm developing a WebRTC application that I have to scale. So this is very common that people want to scale their WebRTC, or I mean the media servers or some parts of the application. So this is really common. Of course, automation, I didn't highlight it because I think Kubernetes is built for automation. So this is something that the final goal, I think, should be to go there, is the main reason. Resilience, so for example, by scaling media servers up and down, how is it possible to avoid losing connections and how to avoid these service disruptions. Monitoring, I won't say that's the majority of our user requests, but there are quite a few people who would like to see some statistics on the running services. Basically, I find it quite fascinating because, as I know from large-scale industries, it takes a lot of time for operators running these complex services just to figure out if they meet their SLAs that they offer to their customers. So this is something that could be useful. And also portability. So it often happens that we meet with clients who are not satisfied with their cloud providers and they just want to move somewhere else. So I don't know if you have ever heard about Argo CD, but it's quite a good thing that you can automatically move from one cluster to another. And this makes it possible if you have your YAML files in place and your Helm charts and whatever. Yeah, and also for this portability thing, so this user is talking about, I would like to get rid of host network true requirements. So basically, if you move to Kubernetes, the idea is that you don't want to own the physical resources. I know we are working on the media plane, so it should be somehow important to us, but this system is built in a different way. So basically, I try to group what kind of questions we usually get. So my first idea was to put here some GitHub issues, but instead of that, I was able to, or rather, chose three big topics that I think all the questions are related to these three groups. So the first one is the networking-related type of questions. So there are people coming from the web world, and they try to run some real-time communication services. So something that they are struggling with is to understand that there is a separate control and media plane and how ICE negotiation works, how STAM works, what to set in a turn server and stuff like that. So this is something that they are struggling with. And on the other side, where we have people with a really deep background on RTC, they get used to own the infrastructure. So I completely understand it because we are coming from this networking background and really like to tweak around with configuration, IP tables, DNS records, and stuff like that. But once you move to Kubernetes, network connectivity is just like a service to you. So maybe so it's really dynamic. So you don't have to configure everything manually. You don't need to own the port actually. The second group is very cloud provider specific. So we ingest the traffic through a load balancer. So before the traffic hits Stunner, it goes through a load balancer. And as many cloud providers we have, they have different kind of features that our users would like to switch on or off. And for that, we introduced these custom annotations that they could use it. So we have a couple of requests on if they would like to set something on the load balancer and how should it be done. And also there are some other type of issues or questions, like whenever you scale up Stunner to different instances, and there are a few load balancer, luckily, that use some stateless hashing mechanisms to hash UDP packets, and as a reason of that, they just randomly put or send UDP packets to the Stunner instances that they just drop it, so they face some connectivity issues. But yeah, we are lucky in that sense that I think we had maybe 3 users experiencing with that, and we suggested them to move to another cloud provider, and that solved the issue. Also, they have problems with scalability, so how they should scale Stunner or the media server or together by taking into account, just to mention that they don't want to lose connectivity. Of course, for being able to do that, you need to have some support from your application, from your media server. I can say that Stunner is not the bottleneck, so from performance-wise. So usually it is like that you only need to scale the media servers, but the good thing is that you can still scale up Stunner. Okay, so let's see some numbers, some stats. So the method I collected these numbers is from our GitHub issues. Discord messages, we have from a lot of threads, direct messages from our clients. I could count roughly 200 individual questions. Of course, some of them are coming from the same group, but targeting different areas. I only counted those answers where our customers shared or users shared what type of platform they use. And there is a disclaimer here, so I'm not sure if popularity, so there is a straight relation between popularity and number of questions. Maybe Chad knows more about that. So I don't know if number of questions on Stack Overflow straightly reflects how popular something is. But anyway, that's what we see. So half of our users are running on Google Cloud or Amazon. DigitalOcean is getting really popular. So last year we have seen a rise in that. AKS is not that popular right now. And we have some people running on OpenStack and on-prem solutions. So when I say OpenStack and Minikube, some of them have been running their own clusters. So basically the way how they get into Stunner is that they come to our repository. We have under docs examples, a couple of examples how you can set up, for example, a one-to-one call or some cloud retro gaming examples. We prepared for them, and for that we use some media servers, and they have the option to run it on Minikube. So basically they used to start there with Minikube, and then they move to most probably to Amazon or Google Cloud or on-prem, basically. What about the media servers? So I think maybe that's a bit more representative what we have, because people usually don't come to us with problems with their media server, since we are not professional on that, so we just forward packets to the media server. And so the typical trends that they start with Minikube, and because it's easy, and KMS is Kurento media server, so I was sad to hear that it's dying. We set up our examples with Kurento media server because it was easy. So we didn't know at that time what are the popular ones and what should we pick. But after a while, our users suggested us to have more examples. So now we have LiveKit, Jitsi, MediaSoup, and actually they are really popular. So I would say that MediaSoup, Janus, and maybe LiveKit, but LiveKit is now dropping since they moved to closed source some important parts of their media server. What else? Yeah, I had to rename this slide actually because original title was exotic use cases, but I just figured it out after the first day here that it's so colorful, this WebRTC community, so it's not so exotic what we have. It was just surprising for us that people using Kubernetes and WebRTC, so roughly 30% of our users are not running video calls or video conferences, but doing like remote rendering. If you have a notebook which is not that powerful and you would need some GPUs, then they provide a service that you can render your images there and just stream back the video. Or Neko, for example, which is a remote browsing utility where people can cooperate, or maybe for security reasons you can run your browser in a distant environment and it will not download something into your machine. By the way, I really like this logo with the cat. We had people using Stunner and Kubernetes for gaming. We had a Cloud Retro example in our repository. I wouldn't consider it like a very hard scale or very deep, I don't know, gaming use case, but we had some people running it with Unity. Yeah, and you see the plant surveyed by the camera. We also have clients who are running this surveillance on like pets and plants and trying to figure it out if they are doing well or they need some special treatment or care or food and stuff like that. And they pipe it into some AI system so that automatically can interact with these animals. Sounds a bit scary, I would say. But anyway, yeah, it's still there. We had a user who wanted to port it, Stunner to Raspberry Pi, which was also a bit exciting. And there was a single user who managed to run Kubernetes and build Stunner on Windows. So hats off. I really love this guy once I would meet him. Actually, it wasn't his choice. They were running some .NET framework thing, and so that wasn't a question to him to do that. Yeah, so basically, that's it. So we meet quite a new use cases after coming from this telco and networking world. Yeah, and we have to talk about, at the end, like, there are cases when you don't need Kubernetes, actually. So if you have already something that is up and running, deployed, it makes you profit. You don't want to do much innovation on that. You don't want to dynamically scaling it. Over-provisioning your hardware is not an issue. Then I suggest you to stay there, just because learning Kubernetes have a learning curve. So doing and maintaining it. So obviously this is something that you have to consider. It's like as you have seen our slides. So most of our users are running on managed cloud services, or those who are not, they have this infra team. So you need to have a couple of guys. I don't know, maybe 2, 3, depending on the use case to handle a Kubernetes cluster, which gives you an overhead. Or if you have a monolith which is really big and it's really hard to break it into smaller parts, then also I would not suggest to try to do that, because anyway, I don't know if it worth the effort. Actually, before working with Stunner, we had a similar problem. So we wanted to move really big monoliths into Kubernetes, and we were playing around how we could break them into smaller parts, but it just simply turned out that it doesn't work to do that. And also, the last bullet point is quite obvious, I guess, for you. So if you want to do some robotic control and stuff like that, Kubernetes adds some latency to your workload, but I guess for WebRTC use case where we are talking about 100 milliseconds, it's not an issue. So the conclusion is that I would suggest you to do the assessment. So if you are willing to move to Kubernetes, you also, I think, it's worth to consider maybe to redesign your application a bit, not necessarily entirely, just to fit into this Kubernetes ecosystem. Otherwise, I think you cannot harvest this highly automated way of working. let Kubernetes do its job. Like, do not try to own the infrastructure and the networking part, like in our case, because we are selling or we are giving a media gateway. The very good thing, I think, is that you don't need to scare or don't need to care about the security issues. Like, you can blame your cloud provider if anything happens because you are behind the load balancer, so they should deal with that. Also, yeah, referring back to the first bullet point, if you considered and you decided to go that way and you are open to do some redesign, then maybe using operators and writing operators, I would encourage you to do that actually, because it really gives you back the mindset which is behind Kubernetes and how your workload can work in an automatic way. So it can give you resilience, scaling, whatever. So yeah, basically that's it. If you, I think, take these steps, then you can focus on developing your application and you have less of a hassle maintaining it. And yeah, focus on developing your really magnificent and beautiful application. So by saying that, yeah, I think I would conclude this talk, and I'm happy to receive questions if you have any.
Any questions from anyone? Boris has a question back there.
Very basic question, but how do clients connect to it as a turn server?
How do they connect to the turn server?
Do they connect to it as a turn server?
Yeah.
And how does it decide which media server to route to?
Yeah, so during this, on the signaling control plane, during the ICE negotiation, we expose the private IP address of the media server to the client. So when it goes to the turn server, it will ask for relay, and it knows the private IP of the media server, so it can set up this turn connection directly to the media server. So Stunner basically just proxies the traffic into the right server.
Great. And can you run it independently without Kubernetes?
Yeah, I think, but we don't advise to do that. So it's the way how we designed it is to fit into the Kubernetes ecosystem, like configuration-wise and reporting and stuff like that. I think you can build it, but yeah, we have a project actually we are thinking about to create a single, so like a standalone turn server from Stunner and do some experiments on that. But we still haven't decided if we will run it on Kubernetes on bare metal or something like that. But since we really shaped this into this ecosystem, we are going that direction.
Great, thank you.
Mateusz has another question.
Thanks for the talk. So it's again about Stunner, not exactly the talk, so sorry. But can you plug another turn server in front of it?
Yeah, but why would do that?
No. But we once...
Wasn't you the guy who asked it sometime? We had a question like, if I can connect Coturn behind Stunner to do some multi-cluster use case and stuff like that, but we just didn't understand why would you do that. But you can.
We once did like a built-in turn server into our SFU server, and people were asking the same.
Okay.
But in this case, like possibly you have like a turn server somewhere, and want the people to connect to that turn server there outside of your Kubernetes network, because it, for example, is accepted by some firewalls or whatever, and that may be the case.
But what's the difference if you are running your turn server like behind the load balancer, like in the cloud?
Like the idea is to like have it separately somewhere else, but since it's not the real use case, then let's not discuss it.
Yeah, I'm interested actually, so maybe we can discuss it offline.
Yeah, sure.
No, thanks.
So answer is ultimately yes, you can plug another turn server in front of it, or no?
Yeah, but I would say it's maybe could be a bit cumbersome to do, but yeah.
Yeah, thank you.
I can see why you do it, why you do a turn server in front of Stunner, but we can talk about that afterwards. It's all to do with getting into organization whitelists and things like that. Because you're right, your Stunner public IP is just the same as, you know, a media server public IP. And we use Turn for very specific reasons. Like we use Twilio's Turn network for very specific reasons.
Mm-hmm.
So I can see why people would want to do it. There's a legitimate reason for it. What was the question that I was going to ask you? Is there a Stunner API? Like how do you tell like the media server, oh, these are your relay candidates, and is it the media server that offers them, or do you have an API where you put in, you know, your turn server into the client, and the client goes and gets the relay candidate? Which direction does it come from? Does that make sense?
I don't know if I can follow, but I will answer and you figure it out. So we implement the gateway API from Kubernetes, which treats like this is like an ingress gateway. And in that you can configure like all the settings that you want, like authentication, endpoints, and whatever. And then on the control plane, you have to give the client which media server to connect through Stunner. So whenever a media packet arrives to Stunner, that's already, there should be a handshake already done on the control plane to do that.
Okay. Yeah, I'll have a think. But ultimately, like the media server is the thing that generates your SDP and generates your trickle ice down to your client. And so at some point, your relay candidate has to make its way somewhere, and something has to talk to Stunner and go, right, where do I talk to? And there has to be like an API for somewhere to be able to figure out what those things are. So I guess I probably just need to take a look at the config for Stunner.
Yeah, we also have a Stunner authentication service with which you can interact with that.
Okay, that's probably exactly what I want.
Lorenzo also has a question.
I don't know, probably a half answer to Dan as well, because if I understood correctly how this works, this may be similar to what Slack was doing a few years ago, where they had their own Janus instances somewhere in the back, but then they always fronted them with the turn server, probably to address a similar scenario, so single port, easier to control and everything. So the media server doesn't even need to know that there is a turn server somewhere. You just expose the turn server to users. Users get the relay candidate and talk like that. And then users will give the address of the relay candidate, which I expect you are giving them the private address, so that the media server can communicate with the, basically from the media server perspective, they are just talking to an IP, which is the relay address, which is in the same private network as Kubernetes is. And so it all works transparently for media servers. So and this is to answer Dan's question probably. So just to figure out if that's exactly how
that's the
works.
case. Yeah. Now the thing is that these are not integrated into a media server, so this is a standalone thing. So you can.
I think I'm going to reiterate maybe the third time, but my question is pretty much similar. So if we have 2 pods which is running and then a Stunner behind that, and then somewhere I want to say that, okay, this client needs to be allocated to this specific media server, I need to do it by providing the candidate, the Stunner candidate. I mean, the Stunner server, your Stunner server as a candidate, and then the load balancer will actually route it to that media server then?
Yeah, the load balancer will give it to Stunner, and it knows which media server to use. So, yeah.
So, okay, so the control can be that I can control
which
which user is specifically which media server it goes.
Yeah,
okay.
Sure.
Okay, thanks.
Does anyone have any other questions?
Well, I kind of had a question, but the answer to the last question answered it. It was, why do you even need Stunner? And it's about affinity to media servers. I now understand.
All right. I think that with that, we can thank Mate for this amazing talk.
Thank you very much.